Mr. Cleland here on this glorious snow day. So today we're going to go through some work because we're off. If you've not out having fun, feel free to have a go. So I've pitched this at a level for S1 and S2, level 3 and 4 fractions. S3 we're going to do expanding brackets review. S4 if you do National 5 apps, or S5 and 6 even National 5 apps, then we're going to look at area and perimeter questions, and for higher we're going to look at some polynomial equations. So let's get started. S1, S2 fractions. I'm going to give you a few examples and then a worksheet. So example 1, 31 divided by 4. We're going to change it to a fraction. So 4 goes into 31, 4 5s are 20, 4 6 are 24, 4 7s are 28, 29, 30, 31, leaving me 3 left over out of 4, so 7 3/4. We can do the same going backwards. If I want to change 4 1/3 into a fraction, I just do 4 times 3, which is 12, and add 1, which is 13. So I get 13 over 3 as a fraction. Adding fractions or mixed numbers next. 4 1/2 plus 3 2/3. We can just do 4 plus 3 at the side and get 7. And then we've got to do 1/2 plus 2/3. A quick and easy way to do this, especially if it's a snow day, just times the bottom together to get 6. Then 1 times 3 is 3. 2 times 2 is 4. That gives me 7 over 6. Now, if that's just a normal fraction, then your answer would be 7 7/6. But since that is a top-heavy fraction, I can change that to 1 1/6. So my final answer to this is 7 plus 1 1/6, 8 1/6. Times in fractions next. Just times the top to get 2, and 2 times 3 is 6, but then simplify your answer, which is 1/3. Obviously also simplify any answers when you add. Times in mixed numbers, so I've got 4 times 2 1/2. Just remember to change it to a improper fraction first. 2 2s are 4 plus 1 is 5 over 2. 4 5s is 20 over 2, which is 10 in this case. Another example like that, 3 1/2, so that's 3 times 2 is 6 plus 1 is 7 over 2, times 2 1/3, 2 3s is 6 plus 1 is 7 over 3, 7 times 7 is 49, and 2 times 3 is 6. And then at that point you would just simplify if you can, but no number goes into 6 and 49. Okay, so if you want to give this a go yourself and you've not got access to any work, here is a little worksheet that you could try. Just pause it here or take a screenshot, and then in a moment I will go to the next slide and you can see some exam questions as well, what it looks like in National 5, even though you're only S1 and S2. It's worth just having a look. So here's some challenge questions that you could try as well. Have a look at these and see if you can give them a go, and I'll go through the solutions to these in a moment. Okay, the solutions to the first one. So 5 1/12 times 2 2/9. We've got 5 1/12 times 2 9s is 18, 19, 20 over 9. 5 times 20 is 100. Taking your time here, 9 times 12, 9 10s is 90, 9 2s is 18, so that's 108. There is another quicker way to do this, but I'll teach you that another time. Okay, now simplify your fraction. So I'm just going to half each number to get 50 on the top and 54, and then half again to get 25 and 27. And then just a quick check, is there any numbers that go to 25 and 27? I don't think there is, so we'll be done there. The next one said evaluate 6 1/5 minus 2 1/3. So 6 minus 2 equals 4. 1/5 minus 1/3. That gives me 15. 3 minus 5. So that is a negative answer. That's minus 2/15, but we can work that out. 4 minus 2/15. I just go down by 1 to get 3, and I'll have 13/15 left over. So that's a little tricky, that one. There's other ways to do that as well. You could have changed it to fractions first and then did it. And then the last one, 3/4 times 1/3 plus 2/7. So I've got 3/4 times the answer to this. 3 times 7 is 21. And then I've got 7 plus 2 times 3 is 6. 7 and 6 make 13. 3 times 13 is 39. And 4 times 21 is 82. Now we need to simplify it. Three times 13 is 39, and 4 times 21 is 84. So I can divide by 3 on the top and bottom to get 13. 3 and 8 goes twice with 2 left over, so 8, 13 over 28. S3, we're going to review expanding brackets using the box method, the area method I like to do. So 2x plus 1x plus 3. If you just draw yourself a box, you can put 2x plus 1 on one side and x plus 3 on the other and just split it up into its 4 pieces. 2x times x is 2x squared. 1 times x is plus 1x. 3 times 2x is plus 6x. And 3 times 1 is 3. Remember, these diagonals go together, so when we're collecting the terms, we get 6x and 1x is 7x. So the final answer is 2x squared plus 7x plus 3. Let's look at a few harder examples, expanding and simplifying. So example 2 says x plus 2 squared minus x plus 1x plus 2. So x plus 2 squared means x plus 2 times x plus 2. And minus x plus 1 times x plus 2 again. So we have got x times x is x squared plus 2x plus 2x and plus 4. And then we've got x times x is x squared. X times 1 is 1x. 2 times x is 2x. And 2 times 1 is plus 2. Now, I'll put a little bracket around this one because we're taking this whole thing away. Notice that minus sign comes into play. So we've got x squared, take away x squared, that's 0x squared. We've got 4x, take away 3x, so we can write 1x. And then we've got 4, take away 2, which is plus 2. So it simplifies to x plus 2. Last example before I let you go yourself, 2 bracket x minus 1 squared. So that's 2 x minus 1, x minus 1. Put that down in brackets just so we know to times everything by 2. So we get x squared minus x minus plus 1. Minus times a minus is a plus. Minus 4 times the answer to x plus 1 squared. X squared plus x plus 1. Minus 2x plus 1 just to hang about. So expanding everything out, we get 2 times x squared minus 2x times 2 is minus 4x. 1 times 2 is plus 2. Then moving on, 4 times x squared is minus 4x squared. X plus x is 2x, times 4 is 8, so minus 8x, that should say squared. And then 1 times 4 is minus 4, and we've still got minus 2x plus 1. So collecting all our terms together, 2x squared minus 4x squared is minus 2x squared. Minus 4x minus 8x is minus 12x, minus another 2x is minus 14x. And then our numbers, 2, take away 4 is minus 2, plus 1 is minus 1. Quite a long and complicated one, but give them a go. They're not all that hard. Here's your questions to try if you want. I've got a standard worksheet to start with. You maybe want to pause the video here and take a note of it, and then come back when you're done, and then I'll show you the past paper questions. Okay, N5 challenge questions, a few ones there to try. You'll notice that these are not quite as hard as even some of the examples I've done, so you should be able to give these ones a go too. Okay, National 5 apps, area and volume. Your key things for area and volume is you need to know the area of a Nash 5 apps, area and perimeter. So for a circle, we have got, this is called the radius, and this is called the diameter. And the area you need to know is pi r squared, and the circumference is pi times diameter. A couple of other ones that you should know, just I'll not go through every possible thing, but for a rectangle, that you've got the length and the height, or the length and the breadth. I'll call it the length and the height. The area of this is just simply the length times the height, the two sides times together. And for any triangle, I'll just draw a random triangle. We need to know its height. Let's just put it here and call it h. And then this bit along the bottom we usually call the base. The area is a half of the base times the height. And we'll just go through a couple of questions that might look like exam style questions where we add in some context and you maybe need to work out the price of something. Perimeter, just so you're clear, is just the distance all the way round a shape. So if you just need to get all the sides and add them up. Here's a couple of examples to give us a go. Example 1 says, a new window of a church is shaped in a rectangle and semicircle. It costs £3.99 for every centimetre of metal for the bars. How much will it cost to make the entire bar? So we have got this and a semicircle. So we will need to work out our perimeter because it's asking us for the whole thing. And we'll probably need this one here as well because it's going to, let's assume that it's going all the way around. So let's just look at our rectangular part first. Making sure our units are the same, so let's just make everything centimetres. We've got 80 centimetres here, we've got 130 here, and then we'll still have 80 and 130. So adding all them up, we get 130, 210, 420 centimetres. So that's my rectangle done. And then my semicircle looks like this. Now, don't be tempted to add this bit on because we've already done it here. So all we need to know is this bit is 80, and for a circle, it's pi times diameter. But since it's a semicircle, we divide by 2. So at that stage, we would get a calculator and work that out, and that would give us 125.7 centimetres to one decimal place. So adding it together, I've got 420 plus 125.7. That is equal to 545.7. So we now know the total amount of metal we need. And now we need to work out the cost. It costs £3.99 for every 40 centimetres. So I need to know how many bunches of 40 centimetres I need. So I need to know how many 40s go into my answer. So the first step is to do 545.7 divided by 40. And this question doesn't state whether I need to buy bunches of 40 centimetres or not. If you had to buy bunches of 40 centimetres and that's all you could buy, then you would round it to 14 because you need to buy 14 lots and have some waste, and you do 14 times £3.99. But let's just assume that you can just buy your exact amount for this question. So your next step is just to do 13.64 times the £3.99, and again that's a calculator job. 54.42. And we're done. Second style question. Calculate the cost to tile the entire floor, assuming that this is our floor. So tiling the floor is the area all the way inside. So I need the area of the rectangle and the triangle. So splitting it up, I've got a rectangle, which is 3.5 metres by 6.5. And then we've got our triangle. And the triangle, well, it's still 3.5 along here, but on the bottom, well, it's not 8 because that's all the way along. It's not 6.5 because that's to here. 8 take away 6.5 will give me that. That gives me 1.5. So area of my rectangle, I just need to do 6.5 times 3.5. And for my triangle, I need to do 3.5 times 1.5, but then divide by 2. They're both calculator jobs. 22.75. 2.625, adding them together, total area is equal to 2.625 plus 22 metres squared. Now that's our area. Now we need to read the question. Packs of 4 tiles are sold as £9.50 for every 2 square meters. So I need to divide this by 2. So for my cost, I do 25.4 divided by 2, which is 12.7. Now this one's talking about packs of 4 tiles sold as £9.50 for every 2 square meters. So I've worked out I need 12.7 packets, but I'll need to buy 13 in this case. So the cost is going to be 13 times £9.50. Which is £123.50. Okay, I've got a bunch of questions you can try going from easy to hard. So you might be able to pause it at various points. The first one is find the perimeter of just these shapes. And then some areas. And then some circles. And then some composite shapes. And then your exam style questions. There's the first one. There's the second one. There's your third one. And there's a fourth one. And a fifth one and sixth one. Getting a bit harder now. Okay, higher maths, polynomial practice, maybe solving some polynomial equations. This one, I'll give you an example and then give you your worksheet. Find the roots of this. The roots mean I need to find out what number for x makes this equal to 0. First step is to find one just by guesswork, okay? So, looking at this last number 6, by guesswork, you can actually, it's factors of this number as long as this is a 1. So, I can try 1, 2, 3 or 6, okay? Let's try a couple, but I'm not going to do them all. Let's say we tried 1. Then we would get 1 cubed minus 4 times 1 squared plus 1 plus 6. Well, that equals 1 minus 4, which is minus 3, plus 1 is minus 2, plus 6 is 4, so it's not that one. Similarly, if you tried minus 1, it wouldn't work, 2 wouldn't work, minus 2 wouldn't work, and eventually you would try 3. Now, once you get the bigger numbers, it's probably straight away better just doing it with synthetic division if that's the method you've been doing in school, or you might be doing long division in another way. But synthetic division is the most common, so you've got 1, minus 4, 1 and 6, and I'm going to try 3 in this case. So I'll get 1, 3 times 1 is 3, 3 minus 4 is minus 1, 3 times minus 1 is minus 3, add 1, I get minus 2, 3 times minus 2 is minus 6, add them together, I get 0. So since f of 3 equals 0, x minus 3 is a factor. Always need that statement when you're doing it, especially in an exam. So we've found one of the factors or one of the roots. Now, factor and root are very similar connected. X minus 3 is a factor, so x equals 3 is a root. Notice the difference in terminology. A root is where it crosses the x-axis. A factor is when it's factorised, but they're very closely connected. We need to find the rest. So we've got x minus 3, x squared minus x minus 2 equals 0. X minus 3, x, 2 and 1 times together make 2. Minus 2 plus 1 equals minus 1. So our roots are x equals 3, x equals minus 1, and x equals 2. And we're done there. Okay, here's some questions for you to try. You might want to pause the video here. And some more. It's been Claire Maths, and today's been a snow day, and therefore I've given you various amounts of work that you can try at different levels depending on where you are. Hopefully that helps you. Take care, stay safe out there, and goodbye.